Hi everybody. Today we're going to be talking about clouds and how clouds form. Alright, so to start things off, I'd like you to think about these three questions. You may use your reference table, especially for the first one, and try to answer them. I'll come back in just a minute. Okay, so some things to recall. What happens to air pressure as altitude increases? So as you go up in the atmosphere, there is less air, therefore the air pressure decreases with altitude. For the second question says, what do we call energy transfer due to density differences? That would be convection. Right, if you think about convection currents, warm air rises, cool air sinks. For the third question, what happens to the temperature of a volume of air that expands? So as air expands, the molecules are moving farther away from one another. There's less interactions between them, therefore the temperature cools down. Okay, so these are the steps in cloud formation. These are extremely important. They always show up on the earth science regents in one way or another. So step number 1. Let's write these down. All right, step number 1. Warm, moist air rises, or sometimes it's forced to rise. And the reason that warm, moist air rises is because it has a low density. Okay. The second step, because the warm air rises, as it rises, it expands and begins to cool. And again, this is because there is lesser pressure as you go up in elevation. Step number 3, if the air temperature cools enough to where it reaches the dew point temperature, which means that the temperature equals the dew point, then condensation will occur. And again, if you recall, condensation is when water vapor, so a gas, turns into a liquid form. Now, when that happens, water will condense onto particles that are floating in the air. So we call that condensation nuclei. I'm going to show you some examples of what that is right now. Okay, so condensation nuclei, think about particles of dust or pollution that's in the air. That could include smoke, right, ashes from smoke. It could be salt if you're near the beach, or it could just be dust particles that are floating around in the air. Now, when condensation occurs, the liquid that is forming needs something to grab onto. And if you look at this picture right here, you can see that this is a dust particle and all of these little water droplets start to grow on it. So now looking here, you can see all of the dust particles are surrounded with water droplets and they're extremely small. Right, so you can look on this side over here to get a better idea of how small everything is. This is a typical rain droplet right here. So if that's a rain droplet, and all these little droplets are condensation nuclei, or cloud droplets, that's pretty small. Okay, so here's a question for you. What kind of pressure do all clouds form in? And the answer should be low pressure. Let's think about why that is. I'd like you to think of an explanation. So our explanation is when you have low pressure, right, warm air, it's usually going to rise. Now, when that air rises, it cools and expands and eventually cools enough to reach the dew point when condensation occurs and then forms tiny droplets, and then you get a cloud. So we just discussed this one before. So when condensation occurs, gas turns into a liquid. So if you think about little tiny water droplets, right, they're extremely small. They're all floating around in the air, and that's what makes up a cloud. Right, so that would be your cloud. But how does this water vapor get into the atmosphere in the first place? Well, the answer to that would be through evaporation. Now, when you have enough cloud droplets floating around, we're talking millions of cloud droplets. They can also be ice crystals if the temperature is below freezing. Those droplets are so small that the air currents keep them afloat or suspended in the air. Now, eventually, if those cloud droplets combine with other cloud droplets, they're going to grow in size, and if they become too large to be held up by the air, then they will fall. Any sort of, or any type of falling liquid, or I guess I should say falling H2O, is considered precipitation. Can you think of some different types of precipitation? Well, the first one that most people think of would be rain. Then you have snow. Next you have sleet, and also hail. You can also have freezing rain and a mixture of all of these. Okay, so just to sum up how clouds form. So here we have a rising air, right? It rises because it has a low density. And as it rises, the air molecules start to expand. Okay. As they expand, they cool down, and just at this level right here, the temperature will reach the dew point. And when that happens, condensation occurs, and that's when all of those droplets of water will start to form from water vapor. Right, so when you think of clouds, think of millions and millions and millions of tiny water droplets that are floating around. Another way that this can occur is if air is forced to rise. So let's say that you have winds that are blowing in this direction. As they hit the side of the slope of this hill, they're forced upwards. Right, so the air is forced to rise, it has nowhere else to go. And this causes the temperature to drop, right? As elevation goes up, temperature decreases. And then eventually at the bottom of the cloud, this is where condensation will have occurred. So this is where the temperature reaches the dew point. So those temperatures are equal to one another, right? Relative humidity becomes 100%, and you get cloud formation. Generally on this side of the hill, you'll get more precipitation. So this side might be more green, right, from more precipitation. Plants thrive on this side. It's usually more humid over here. So this would be called the windward side of the hill or the mountain. So different types of clouds that you may have noticed in the sky. Cirrus clouds are usually white, thin, wispy clouds, usually at high elevation. So I'm going to write high elevation. Cumulus clouds are the puffy ones. They're the ones that look like cotton balls. Stratus clouds are usually very, very long. They cover most of the sky, and they're usually low in the sky. And then fog, if you're familiar with fog, is just the cloud that's near Earth's surface. Here's a picture of the cirrus clouds. You can see they're kind of wispy, usually very high elevation. Because they're so high up in the troposphere, it's very cold. Often they're made out of ice crystals. Sometimes they can take some pretty neat shapes, so this would be called a jellyfish cirrus cloud. You can kind of see it's got like a jellyfish head, and then the little tentacles coming off. These would be your cumulus clouds, so you can see they're kind of puffy, look like cotton balls. Stratus clouds are usually very stretched out, kind of flat. This is taken from an airplane, so this is on top of the clouds. Fog, right, if you're standing near Earth's surface. Now, if clouds produce rain, we also have another name for them. So nimbus means rain. So let's say you have low rain clouds. Usually that causes slow and steady rain. We would say that they were stratus clouds, but if we add nimbo to the front, they become nimbostratus. So nimbostratus clouds are low rain clouds, slow and steady rain. Cumulus clouds, if they produce rain, we add the term nimbus to the end of it, right? So this is cumulonimbus clouds. These are usually associated with really short and heavy bursts of rain. So short, heavy rain. Think of thunderstorms, especially in the summertime. So here's some pictures of a nimbostratus cloud. You can see it's very low to the sky, right? Covers most of the sky, right? It's very gray. And the reason that it's gray is because the sunlight cannot penetrate through the cloud. So it's dark on the bottom. And then here you have your cumulonimbus clouds. Sometimes they're called anvil clouds. They get really, really large. Right, so this is the whole cloud. Kind of looks like an anvil. And usually the taller the cloud is, the stronger that the storm is going to become. So that's it.